All right, all right, all right. All right, so we're starting. We got our start stream up, and yeah. Still going a little slow. I think with the Discord and the Streamlab, it's probably gonna like slow stuff down. But I think that's just kind of naturally what we're gonna do. As y'all can see, my overlay is still crazy. I gotta figure out how to change stuff from latest followers, like all this overlay stuff. So just work with me, please. Work with me. All right, do a quick little sound check. Yeah, it's pretty much running Discord, and this face is gonna be killer. Okay. What I might do is close out Discord and just use just YouTube, but we'll see. Depends how slow it is. All right, what is actually okay? They're actually showing background. What I'm doing is trying to. I'm gonna go ahead and put this in the chat, Lucy. Whenever you get a chance, I really appreciate it if you can click on it and drop a like. That is the YouTube thingamajig. Super appreciate it. Alright, what is actually? Oh, let me close this out because it's gonna be an echo. All right. Righty. Okay, so let's go ahead and get started. All right, we're gonna do our import statements, continuing on from yesterday. As you can see, it's moving way faster. Like if you watched it yesterday, you realize it was just hanging, and that was part of that was collab too. So it's still not working that fast, but it's not doing it like it was yesterday. Okay, all right. So here's what we're gonna do. This is the tabular one from May 2022. As you can see, what I'm gonna do is I'm actually going to duplicate this one because it's very similar with like importing the statements and all that good stuff. So let's first of all, let's open get a new tab for our notebook. I can watch. Close this. Yeah, we're definitely running Discord and Streamlabs is definitely gonna be taking up its toll on my processing power for my MacBook, but let's just open. I'm just gonna open the previous one. Trying to make it all sexy and stuff. Nah, man, just copy and paste. All right, so this is the May one that I've been talking about for 2 days, and we're just gonna change it from June to May. Also, let's open this up. So I'm gonna end up reading these directions probably 50 times so I can understand really what's going on. I think that's a big part of the process. Sorry if I'm kind of fading in and out, but big part of the process is going to be pre-processing and EDA, which is the exploratory data analysis. And also, before you even start coding, you should be wondering, like, why am I actually coding? That saved me a lot of trouble. Let's open this up. Okay. No, not 6.5. 6.6. Whatever. It's supposed to be 6.6, but whatever. On my YouTube stuff. Whatever. Okay. Yeah. Okay. So, yeah. This one's a little different. So we're giving, I think last time we even had manufacturing control data, but this contains actually missing values due to electronic errors. So that's what we're going to be looking for. Your task is to predict the values of all missing data in this data set. That's interesting. Note, while there are continuous and categorical features, only the continuous features have missing values. Here's a notebook that you can use to get started, which is always best to kind of, if they have a notebook, the last one didn't have a notebook. If they have a notebook, kind of use theirs so you can kind of see what's what and not putting your old code in there and your code is messing you up. All right. Okay. All right, cool. So they just basically have your basic import statements. So I'm just going to basically copy these. Obviously we're going to be using NumPy and pandas. Keep a lookout because I'm actually working on a pandas one right now. I actually got a good deal of it done. Right now I'm just adding and editing it, and I'm gonna try to have it up by the end of the week. But okay, so let's just get these import statements knocked out of the way. We got a lot of them already. I think the only thing we are missing is pathlib, tqdm, which I'm not sure what that is, and sklearn impute. We're gonna need that zip file too. All right, so we're gonna import those. We got our sklearn impute. Next, we're going to have our path. That's nothing different, except there is a submission folder we're going to be creating, I would imagine. You know what? Let's just get all this. Let's just grab it all. Input tablet. I think ours is just data, like CSV or something like that. What the hell, man? All right, we're back. All right. So from here we're importing need PCA standard scalar. We're obviously going to want our matplotlib and Seaborn. Okay, and we haven't gotten to actually importing the data yet, have we? No. Okay. So there's actually some pre-made functions. There's an EDA function for SweetViz. There's an EDA function that creates a pandas profile, and there's an EDA that does AutoViz. Okay, which is a data visualization. All right, so now we're getting into the import. Yeah, I think Kaggle, not Kaggle, but I think Discord and what's his face, Streamlabs and Discord is a killer, but it's still workable. Okay, we got our EDA. So our EDA is finished. Now we're going to be mounting our Colab drive or our Google Drive to Colab, same as we were doing before. Okay, and see, now we got our path variable, so now we can kind of go back to that and see that Tabular Playground Series 2022. I don't think it came with the Tabular Playground Series. I think it's just data.csv that we are actually importing. Yep. Yeah, of course, man. Google Drive, man. Yeah. I mean, I think Colab is just slower in general because it's using all this stuff in your memory, and you're using Google's online resources. So you kind of got to deal with what you kind of have to, but we can still set up our path variables, which is at data.csv, I want to say. So right now I'm just kind of going through my Google Drive, trying to, I don't know if it ever loads up, but trying to, there it is, find a data set that I'm using for this particular one. I think it is actually, where did I save it? Did I save it to, I might have saved it to Kaggle. There's a problem. You never remember where you put stuff. That's the problem with being human, I would imagine. Alright, I think it's in here. Data science. Kaggle Live. Truth be told, I don't even need all this extra stuff. Okay, so let's delete this. And that. What the heck is this? MP4. Ah, okay, gotcha. All right, so we're gonna go ahead and get rid of all this stuff because that stuff is terrible. Then we're gonna go to the data set, which should be in the previous state. There it is. There it is. Now we just need to point. Oh man, still doing that drive stuff. It's gonna go real slow. Anyways, whenever this finishes, it'll mount this drive. It really shouldn't be taking this long to mount the drive. Well, that keeps going, I guess. Train, we're not gonna need this. Only gonna need one path variable for this particular one because we are only getting one. We are only getting one training set this time, which I appreciate because I certainly did not understand why there was two. Should not be taking this long to do a drive. Four minutes amount of drive should take like 10 seconds. Yeah, this thing is going slow. Should not take 4 minutes plus to mount the drive. It's going slow. I'm thinking about just doing Jupyter. Because this is kind of ridiculous. You know what? Give it another 10 seconds. If it's not done another 10 seconds, I'm going to do Jupyter. Because we've been playing this game for 2 days now. And it sucks. Okay. Yeah, let's go ahead and stop that. Go ahead and stop that. You know what? Let's try it again. As fast as it's going and it's loading up, it should not be spinning for that long. All right, I'm allowing you to access it. Looks like it's going a little faster this time. You can see kind of a little bit of activity in there. Alright. There. See, that's how long it's supposed to take. It ain't supposed to be sitting up there spinning for no however long. Alright, so now we're going to navigate to the actual data set. That I just seen it. Where is in this? Okay. I think it's a 6.5. I should have one full folder for all the projects and stuff, but I got them based on dates. I might want to change that. Yeah, data that. Well, first, I'm gonna have to unzip this. Unless I got one that's in here already. I'm gonna have to unzip this. All right, now we're just kind of setting up our data. All right, it's gonna unzip it all. So let's take out these comments because you only need to zip one time from path. It's gonna zip it. It's gonna read it. How long this gonna take? All right, we shall see. It's the only thing I got going right now is just this zip. Oh, see, that didn't take long. We don't need test train. Should I just call it Avengers DF? It didn't split. I'll call it train for right now. I'll call it train. Train IDF. And we'll name it like Avengers Train or something like that. So it's easy. We'll do that. Oh, what do I gotta say? There's nothing near. No search phone. No. Oh. Why do I? Okay, so that path is set up. So can I just content Avengers Train? You know what? It should be the CSV that's in here. Data.csv, that's what it should be. Okay, now that we got our training set inside of a data frame, well, whenever it finishes, that is what we have. We have data, we have our ID, we have target, I thought this wasn't gonna have a target column. Is that the right one I downloaded? It should be data.csv. Because I remember the other one was in train.csv, test.csv, and then it was sample. Or sample submission or something like that. It's 83 columns. Okay, well, I guess that's what it looks like. Yeah, that's gotta be it, because I know for a fact it was like train or something, DF for the first one. That's why it says sample right here. Alrighty then. No. So we just want to see the first 10 rows. No, really. We want to see the first 10 rows. Man, come on. This shit's going slow. Right. So I'm just trying to see the first 10 rows of this data frame. As you can see, all the IDs, row ID, that's something we really won't be needing as much, but there are, okay, so there's no target. Yeah, okay. So F4 underscore F underscore 414, so 14 column. There are 14 columns. 15? 1, 2. So it's 15 columns. Well, we'll get to shape in a second. So, all right. So now that we have that set up, let's get our info on it. Yeah. Okay. No. Okay, well, we gonna see how many null values it has. There is no test df. We can get rid of that.
Yeah, I never understand when it says not null, but there are no values.
Yeah.
In the box, so.
We're about to see once I get the sum of the and see if there is none, because it says. Well, I haven't run it yet, but I'm about to run it in a second. But well, let's just run it and see. Yeah. So there's a lot of null values. There's a whole lot of null values. There's so many null values that they're actually skipping the you see how it goes from 0, 1, 2, 3, and then it goes 10, 11, 12, 13. Yeah, because there's so many. Yeah, it's skipping those ones in between because there's so many. So unlike the last one, this one has a lot of null values, and that is the entire point of the project. So let's go ahead and describe it. This will give us a summary of the median, the max values. Whenever it decides it wants to finish. How long we've been streaming? Oh, yeah, 25 minutes. Okay, so look at all this. Okay, wow. The mean for row, well, that doesn't really mean anything. Row doesn't really mean that much. Standard deviation. How did the save fail? I'm gonna need you to go ahead and do that. Yeah, save. What you mean? Okay. So, again, we don't need this. it's getting eaten up on my memory. That's what's going so slow. All right, let's get rid of this test. All right, ready. All right, so now we're gonna start doing some categorical EDA. This actually isn't mine. Okay, and we're gonna try to get some columns with and a categorical. Oh, what? I may have to change this value because printing the count of each unique value in each column. 50. I don't think this is gonna apply to ours. Let's go ahead and just get rid of that. We won't need this at all. Well, eventually I'm gonna split these up. I'm gonna split these into our training and our testing set. So I'm not too worried about this. All right, so now we're gonna check for duplicates. Okay, let's check for duplicates. Is that are you Lucy your YouTube? Hi. Hi effects FN. Hi effects FN. Somebody in the chat room. Hold on. Okay. All right, I can see a little better now. All right. So there aren't any duplicates. Of course, you're not gonna need this one. All right, so now we're starting PCA. If anybody who doesn't know what PCA is essentially, well, it's called principal component analysis. Basically, you're separating all your data points into different clusters, and you're trying to distinguish between each cluster as being a component. Each component is essentially an important, I want to say important, significant. That's whatever, but it's a important point, and it's like a point in your predictions that you predict is the most accurate. So let's say you have 5 clusters. Those are 5 different of your most important clusters, and are thus themselves components of the entire prediction. So let's start off with our PCA right now. I don't know how long this is gonna take, but I'm definitely not gonna run TSNE. I don't even, am I saying that right? TSNE, whatever. But I'm definitely not gonna run that because my computer will probably explode if I do that. So let's not not get ahead of ourselves here. Define a number of principal components. So what we're doing right now is we're going based on a vector of our trained DF. We should have trained DF scaled. Okay, so that scale is based off what? It's based off the PCA columns, right? So we're gonna define the number of components, and then we're gonna find the principal components, which is the most significant components, and we're gonna put that into a data frame, and we're gonna transform it right here with our scale training data, and we're going to use that as our target. All right, and then the percentage of the variance explained by each principal components. We're going to print that out, and that's going to be our variable experience. exp underscore var is the percentage of the variance between the components. Let's run that. Uh-oh. We already got a nasty little error. What is the problem? Input contains non-infinity or a value too large for type. See, like, yeah. So now we're already running into the problem of our data set. All right. So now I won't be able to fit this because there's so many non-values, NaN, aka null values, that we're going to have to figure out a way. First of all, I believe we could just get rid of all the fields that are null. But I think what they want us to do is replace those with some particular value. See, like I said, we're going to keep going back and forth in between the objective and this. Let's go back to the overview. Or maybe I gotta go to the data. Okay, you're given a simulated manufacturing control data that contains missing values due to electronic errors. Your task is to predict the values. Okay, you want to actually predict the values of all the missing data in the data set. So let's see. Because we're not even going to be able to get this far until we can actually kind of get rid of that.
I'm just kind of curious how PCA, why is PCA needed in this?
Well, it's just depends on how you want to separate your clusters into components. PCA is just probably the first way you want to separate all your data points. The reason you want to separate all your data points because you want to distinguish between the differences of your data points, and those are going to be your features. So let's say, for example, one feature is age, another feature is sex, another feature is income, another feature is age or whatever, right? So you want to separate those components so that your algorithm knows the difference between each data point, and it can say, all right, this data point is most closely related to this component, which is age. So we're gonna put the data point near this data point, if that makes sense. Lucy?
Yeah, that definitely makes sense.
Well, let me know if I can't explain it well enough.
No, I think it makes sense. I was just kind of thinking, especially since we have so many null values, we have to kind of aggregate features to get a better understanding of how they relate.
100%.
That makes sense. Okay.
Yeah. So that's this is the inherent problem that we're facing for this challenge, is to actually be able to predict when a value is null and be able to predict what that value would likely be. And that is the challenge of this where we're at. So let's see. So a lot of stuff, we can't necessarily use all of it. Let me go back to those null values. The sum. Was it down here, was it? Training info. There it is. Okay, so you can see it's F1 has 18,397 null values. So what we could do to start off, and this is where the note game comes in. Okay. Alrighty then. So what's the objective? Alright, the objective is to find... Alright, so I'm going to put Kaggle, June 2022, TPS, challenge, whatever. Alright. And the objective is to Where we at? Okay, yeah. Find the missing values due to electronic errors. So it's a good idea before you start coding anything. And that, again, this was one of the reasons that I got stuck on coding. Like, this is some years ago where I got stuck on coding. One of my biggest weaknesses was that I would always just start coding and just kind of hope for the best and kind of figure it out. And then you get stuck because you're like, I don't even know what the hell to do. I'm so far into it and I can't really turn around, but it doesn't work like I wanted to at all. And I don't know why. The reason you don't know why it's not working is because you didn't take the time to kind of map out everything, which really engineers should be doing a lot more. We're not even talking about pre-processing. I mean, pre-processing is just, so we're going to start with the goal. The goal is to find missing values and try to break it down as much as possible. That's really what you're doing in engineering anyway. You're breaking down this really big, complicated, kind of abstract problem into something a little more understandable, that you can understand it 100%. So you want to be able to understand it as much as possible. That's why you want to break things down. So find missing missing values in the data set. The data set, that's the first task. That's one. I'm just gonna put goals up here. Goals. Yep. And the second goal is to replace them, right? Attach the predictive values of all missing data in this data set. So predict values of missing data. Right? And that is the main goal of this entire thing. While there are continuous and categorical features, only continuous features have missing values. Okay, yeah, okay, that makes sense. Okay. So, now that we know our goals, how are we gonna go about it? So first I want to say that, like we just said, that okay, fine, we found all the missing values, right? That's like the first thing we've done. But look at all those. That's described. Where's the missing values? I just seen it. Okay, yeah. So first thing we've done. Step one. Find all the missing values, which took us 10 seconds. All missing values is done. Next, we should decide whether, I don't know if they want us to replace them, but I definitely want to see what the values are in each column. I think head, or actually, I think head might be better, or describe. That's the summary. I want to see the actual values of train. And I think it is not info. There it is. All right. So you're looking at the numbers. I mean, it's a bunch of floats. It's a bunch of floats, as obvious. I'm not sure if it's based on like a regression or something, or are these just random numbers? Well, the good thing is it's a float, so it's not like it's gonna be like too categorical. It's continuous values, like it said, but you can see where it says none. What I want to do, See, I could do it a number of different ways. I could say we want to replace all the values, and if the values are, let's say the values are negative. We could say, like, if it's negative, then it's 0. If it's anything less than 0, then it's 0. That's just basically what I'm doing is the RailU activation. I'm actually just saying it out loud. But in terms of prediction, so you could say if it's less than 0, then we're just gonna say it's 0 when we start feeding this stuff into the neural networks. And if it's anything greater than 0, it's 1. So we're gonna have 2 categorical what they call cross entropy. So this is the stuff I'm talking about right now is the machine learning models that we are going to be using to predict when each value is non. Non is just null. So right now, let's see how much time we got left. Okay, we got about 20 minutes left. I'm only gonna be on here for like actually, you know what? I don't want to go too far because I said I was only gonna be on here for an hour, but I've been streaming for like 45 minutes. But Lucy, I'll be done at 10. I'm just gonna explain over what I think that we could do, and then say it again.
Oh yeah, just listening.
Yeah. Okay. I was gonna say, I'm just gonna explain a little bit what I think we can do to try to approach this problem, and then at the 1 hour mark, I'm gonna cut it off, and then we'll continue this on Sunday, what's today, the 6th or the 11th or the 12th. Yeah, so Sunday the 12th, and we'll just we'll start off square from there. But what I'm really thinking about doing for this is, I mean, even if we can't do the PCA, what I want to do is start running this through some machine learning models, because you can see all this stuff is what we've gone through. But until we figure out, like, do we either want to replace all the values with 0 before we start moving into the PCA, so that way there aren't any non-values, or do we want to start like just by normalizing the data and just sending them straight through the models and just start getting into predicting. It's really kind of on us how we want to do. I'm definitely gonna do more off the stream and just kind of just figure out which works best. I mean, the whole purpose of this is to just experiment, learn, have fun. Also, for the competition, let me go ahead and not necessarily all the way stopping, but let me go ahead and kind of get into this other one. Competitions. Because I want to talk about the actual real competition, which we're not going to be streaming. But maybe I'm thinking on... maybe on Sundays we'll have the first hour we'll stream it, and the second hour we won't stream after that, or something like that.
Yeah, that sounds good. I'm down.
Okay. Can I not be a part of more than one? What? Am I not on it? Okay, I'm on this, right? All right, so this is the one. This is the Japanese JPX Tokyo Stock Exchange for prediction. This is the one that we're going to be doing, and this is the one we're really gonna be like going deep in. The tabular ones are just for fun, so people can learn how to actually do these competitions, how to actually start learning how to do the machine learning stuff, how to do data science stuff, recommendations. With these Kaggle things, you can pretty much do all that stuff. whatever works for you. But for this particular part, because I want to start doing these Kaggle competition lives once a week, maybe twice. Once school starts, we'll see how busy I really get, but at least throughout the summer, at least doing these like once a week, and 2 if possible. So we can really start getting these in, and people can start joining these competitions with us. That's one of the main reasons why I am streaming right now, so that people can join in. If they can't join in on the Discord, they can join in on the YouTube situation. So yeah, that's probably what we're going to be doing more and more. As long as people want to do it, I'll do it. I enjoy the competition. So I think we're gonna go ahead and stop it right there. Lucy, if you wanna share your whatever you want to promote, I know you got some NFT situations going on, but if whatever you want to promote, you can get on it before I close it out.
Thanks, Tim. Well, I just want to thank you for hosting this. It's awesome kind of seeing how your brain works, and just learning more about competitions and coding, so that's great. I'm going to Consensus Conference this week, and there's a Web3 hackathon. Just whoever's interested in that. The website is...
You could drop the link. If you was on YouTube, you could drop the link in the chat, but yeah, because that way it'll stay there after the YouTube is finished streaming. Yeah, please do. So that way people can, come up here later and see what you're gonna do.
Yeah. Well, thank you so much. The competition is from June 9th to 12th. It's really short. I'm focused on generational wealth and how we can create that through blockchain technology. So I'm gonna drop it in, but thank you so much.
Oh no, man! Blockchain is. We've been having our debates, so I'm definitely looking forward to discussing blockchain more with you, and crypto and all that good stuff. Lucy just had a conference, right? It was like a crypto conference.
Yeah, we hosted the NFT ATL Con 2022 2 weeks ago. Amazing conference, merges diversity, equity, and inclusion with technology and culture. So just brilliant minds from our communities of color, just sharing what they know about the Web3 space. So super fun. Mayor Andre Dickens did the welcome address. So just really great people in the room.
Is he the mayor of Atlanta?
Yeah.
Is he?
He's actually the mayor of Atlanta. Yeah. You know your stuff. Get it ready to come down.
I'm trying to figure it out. Like I don't know nothing about Atlanta. I just know like a couple of things. Like I'm trying to figure it out. So, that's dope, man. And you organized that whole thing yourself?
Yeah, me and a team of people. I came in towards the tail end, and we're already planning the next one next year. So really, really hyped, really excited for it.
Okay. That sounds cool. Lucy definitely wants me to attend. I definitely would want to attend. I would be honored. That definitely sounds like something that I would hopefully be able to add something to. So, definitely. With that being said, I don't really have anything else left. Lucy, I appreciate you stopping by. We're gonna be doing this again on Sunday, so hope you show up.